Mike Baker.
Hey, nice to meet you.
Good to meet you, man. Good to meet you. And Dan, what do we have here?
So what we're doing today is 3D scanning this aircraft, and we're using this scanner, which is a long-range hemispherical 3D scanner.
What does this do?
So what the scanner does is it spins around, it shoots out a laser, and it's shooting out 1,000,000 points per second, and as it shoots out, it picks up the 3D shape of the aircraft. What we want to do is we want to be able to take this airplane and get it into a 3D computer design system.
Okay.
So we can work on it, design it, or reverse engineer it. And in order to do that, we use a device like this. It's like a camera, but we're doing it in a 3D shape. We're going to use this device for the large areas, and then we'll use some different technology to get into the tighter areas like the gun and up in the cockpit.
Okay, so walk me through this. What exactly is happening?
Right. So this is a handheld laser scanner that Dan has. This thing emits 22 blue laser lines. Well, he can hold this in his hand, and it's like digital spray painting. He just keeps moving around to get into all of these areas, and it's picking up that 3D shape that you see there on the screen.
That's incredible. What sort of resolution are we talking about?
So this will go down to 0.1 millimeter resolution. We have so much detail in here, especially for like a gun assembly. We need that accuracy and that resolution in this area.
Do you mind if I give it a
Sure,
shot?
absolutely.
Okay. So just hold that. This is the go button. And once. All right, so the colors indicate whether you're the right distance or not.
As long as it's green, it's picking up 3D data. So you want to be about 10 inches away, and that's when the cameras can see the laser lines.
I'm just imagining all those years ago, right? The Red Eagles ground team, they get their hands on a MiG, and then they pull out their notebooks, cameras, their tape measures, and they're just taking every little recording that they can, and then going back and doing drawings.
Right. They would spend days to weeks on this gun assembly, and we could easily scan this whole thing in a few hours.
If an entire airplane can be easily scanned, why bring back a black file squadron known for reverse engineering?
And then could you, for example, 3D print a copy of the MiG?
I'm 3D scanning a Russian MiG in order to reverse engineer it, something that 30 years ago would take the Red Eagles engineers months to accomplish. Today, they're likely using technology just like this.
With the MiG, what's the most difficult part of this aircraft to scan?
Fighter planes like this, the hardest thing to scan is the cockpit because there's so much stuff inside there, but yet it's so confined. It's very difficult to get in there and 3D scan that whole area. For that, we're actually going to use a different scanner.
Oh. So just this button right here.
Yep.
Okay.
There you go. And then you can just move around just like the other scanner. It's like digital painting.
Does it function in much the same way as the other handheld scanner?
Well, it's similar and it projects out a light, but it uses LED light source instead of lasers. And we're collecting about 1.5 million points a second. Because this one's actually looking at the 3D geometry and matching up each scan as it goes along.
Now, you finish this process, you scan the entire aircraft,
Right?
you create that model. What do you do with that data?
Well, the first thing we can do is analyze it. For example, we could do, flow testing to look at how the airplane flies. We can do structural analysis.